Today, refraction at a spherical surface. So you can see here this is a curved surface, a spherical surface, and the reflecting surface is outside, and here this blue portion, let us say it is of refractive index N2, and this white portion is refractive index N1. Let us say this is air and this is some water. We want to see how the refraction actually happens. Okay, now here you see that O is an object, and this O is creating a image at a point I. Okay, see the center of curvature is on the right side. Let us say the radius is R. OM and this point M, and let us say you draw a perpendicular from N. Let us say this M dash, they are almost very close. That means aperture is very small. So the small curved portion and this straight portion, you can consider it as same only, almost. I'm talking about I'm saying, if you take this vertical portion and this curved portion, they're almost same because its aperture is very small. So OM is the object distance, MC is the radius, and MI is the image distance. So in this triangle ONM, you can say that tan NOM is equal to opposite by adjacent, which is MN by OM. And similarly, if you take triangle NMC, here also tan angle NCM will be opposite by adjacent. Opposite is NM, adjacent is MC. And in triangle NIM, angle NIM is equal to tan of, that means opposite by adjacent. Opposite is MN, and adjacent is MI. Now you know that these angles are very small, so the tan of the angle and the angle will be almost equal. Usually in mirror derivations, we make this assumption because the angle is very small. Now we are trying to establish a relationship between the distances and the focal length or the radiuses. We are trying to establish a general relationship. Now look at the triangle NOC. NOC. You can see that this I is an exterior angle. So this exterior angle will be equal to NOM plus NCO. Okay. So NOM plus NCM. NCM or NCO, both are same only. Okay. Now look at NCI triangle. NCI. You can see that this angle NCM is a external angle in that, which is equal to the small angle R plus this NIC. This is what I have written here. NCM equal to angle R plus angle NIM. This angle. Okay. I'm talking about this angle. Okay. Now from here we have already got an equation for I. Now we want to get an equation for R. What is R? R is the refraction angle, isn't it? So you have to draw a normal, and you have to see this ray has bent inside. So we have to see with respect to the normal. The normal is passing through the C. We have already discussed this point that if you connect this C and this point, there will be a tangent over there. So this CN will act like a normal. Okay, and this ray, our ray is the blue line. So the angle between them is the angle R. So from here we'll get the angle R value. Angle R value will be equal to NCM minus angle NCM minus NIM. This is what is here, angle NCM minus angle NIM. I value we can write from here, angle NOM. We can get the value of angle NOM. Tan of NOM will be equal to NOM only. So NOM will be equal to Mn by OM, and NCM will be equal to Mn by MC. So we got the values of I, we got the values of R. Similarly, R also can be written like NCM. You just look for NCM, it is Mn by MC, and NIM. NIM is Mn by Mi. We have just put the values over there. Now we know the value of R, we know the value of I. Then we need to apply the Snell's law. Whenever there are refraction is happening, always remember this Snell's law. The way to write Snell's law is take n1 multiply with the corresponding angle. Here it is angle I. So n1 into sine I equal to n2 into sine R. N1 into sine I. This is the medium one. This right hand side is the medium 2. Because angles are very small, I can say that sine I is equal to I. So n1 I is equal to n2 R. Okay. Now from here we need to solve it. So for solving, what we will do is we will just put in the values of I and R. I value, what we have got, this Mn by OM etc., that we will substitute here, and R value we will substitute this Mn by MC value in the right hand side. You can see here that Mn is common in both the sides, so just cancel that. Then you get Nm, and you bring MC terms on the other side and all other terms this side. So you get N1 by OM plus N2 by Mi is equal to N2 by MC minus N1 by MC. Why you are bringing MC on the other side? If you look at the diagram, MC is R, so this is a common term. You need to just put in the values now. So finally you have got this N1 by OM plus N2 by Mi, right, is equal to, denominator MC is common, so you can write N2 minus N1 by MC. But if you see OM is the object distance, which is U. So the rays are coming like this and you're going against, so U value is negative. V value will be positive. Mi value is V. You are in the direction of the rays, so V is positive and R is positive. Okay, so once you substitute all these values, you understood the reason why I have taken M1, Mi and MC as positive values, because they are in the direction of the rays, whereas OM is in the against the direction of the rays. So finally you get this equation, N2 by V minus N1 by U is equal to N2 minus N1 by R. So this is the equation you are supposed to remember when you're talking about so this is the main equation. Important equation is this. Okay, so this equation you're supposed to remember. Thank you.